I just scrolled down a little bit. You're a little bit confused, a little bit baffled, aren't you? So am I when you start reading this very, very, very strange solution from Socrates. But Meno is going to call him out on it, so that's where we're. Meno, yes, Socrates, but what do you mean by this? That we do not learn, but what we call learning is recollection? Can you teach me how this is so? He doesn't think it's the case, but try to prove it. Socrates, I said just now, Meno, that you were naughty. Strange word, naughty. And now you're asking if I can teach you, although I say that it is not teaching, but rather recollection, so that I might at once be shown to be contradicting myself. The idea is, Meno, you're catching me on a paradox with your paradox of inquiry. Now again, you're trying to tell me, your paradox showed you can't be taught. So now you're trying to get me to contradict myself? Meno, no, indeed, Socrates, I didn't speak with this in mind. He wasn't trying to trip him up, but from force of habit. He didn't really mean, can you teach me? He understands the paradox of inquiry. But if you can in any way show me that it is, as you say, show me. That is, hey, just what the heck are you talking about? Why is this true? Socrates, well, it isn't easy, but I'm willing to try for your sake. We're down the line, towards the end of the line where that B is, 82B. Call here for me one of your many attendants here, whichever you like, so that I can perform the demonstration on him for you. Certainly come here. Is he Greek at any rate? ... So here it is. We have the slave boy. He's coming in here. And now we're going to watch what Socrates will do. And he's going to do a demonstration. He's going to start with drawing a square for the slave boy. Let me get over to the text again and get on to the next page, because this is where everything starts. And you see the diagram. Tell me then, boy, are you aware that a square figure is like this? It says Socrates draws A, B, and C. Okay, so what are we getting? That's where Socrates is. He draws that. Ask the kid, are you aware that that's a square? Yes, I am, the boy says, down line C. Okay, so far, nothing strange going on. So a square figure is one that has all these lines, AB, BC, CD, DA, and all the lines are equal, being 4 in number. That is, there are 4 sides to a square. Boy, certainly, Socrates says. And doesn't it also have these here across the middle? And Socrates now draws 2 lines. Let's just take a look at, he draws 2 lines, EG and HF. Says, we can draw these lines as well, can't we? Boy, yes, Socrates. Well, could there be both a larger figure of this sort and a smaller one? That is A, B, C, D. Could you make a big one and a smaller one? So far, he's told the kid nothing, right? Certainly, kid says. Socrates, then if this side were 2 feet and this side were 2 feet, how many square feet would the whole be? Let's go back to a diagram and take a look and see what he's saying. He says, look, AE and EB, if each of those is a foot, that is, E divides AB in half, divided in half now lengthwise. If it's 2 feet by 2 feet, let's see, that's the first question. Could it be 2 feet by 2 feet? And he said, how many square feet would the whole thing be? Look at it this way. If it was 2 feet in this direction and 1 in this direction, wouldn't the figure be 1 times 2 square? Now, he says, he says, if it was just, he asks him, how big is it? The kid doesn't seem to be sure. He says, well, wait a second, if it was this, just this thing, it was 2 in this direction, but only 1, how big would it be? Or does he tell him? But he tells him, but that would be 2 feet by 1 foot. Or 1 times 2 square feet. That's how big the entire square is. Yes, the boy agrees. So he's been told to. But since it's 2 feet in this direction and 2 feet in this direction as well, that is, since it's just not across but it's down, isn't it twice 2? It's 2 times the size. Boy, yes. So it's 2 square feet. Okay, so let's just recap what Socrates told. Socrates now told him something, though. He says, right, if it was just this one and this one, it would be 2 square feet times 1. But since it's 2 in this direction and 2 in this direction, it's 2 times 2, which is 4 square feet. Now Socrates has helped him out. Let's think of what we're going to keep that in mind, because maybe that invalidates this whole demonstration. But let's see. Then he asks him, okay, how many are twice 2 square feet? You know, work it out for me and tell me. The boy, let's say, adds it up and he counts out the squares. We now have 4 square feet. Yes, he's right. Now, and we're on line over here between D and E. Okay. Well, could there be another figure twice the size of this one, ABC, but like it having all its lines equal, just like this one? Can you have another square? The question that he's now asking is, can you have another square twice the size of this? He says, yeah, and then how many square feet would it be? And the boy says something twice the size, 8. 2 times 4 is 8. The kid either knows his multiplication tables or he knows how to add. Come on and try and tell me how long each line in that one will be. 4. In this one it's 2 feet. What in the one in which what in that one which is twice the size? That is, if we're going to have to make it bigger, we're going to have to extend it. How far are we going to have to extend this line? And how far are we going to have to extend AD so that we get something that's the right size? And here the boy gives an answer. We're now in E, but at the bottom. Well, it's clear that it will be double. Now Plato stops. Socrates stops. He says, do you see, Meno? I'm not teaching him anything at all, but everything is a question. And now this boy thinks that he knows what the line is like that will produce the figure of 8 square feet. And Meno agrees that what he thinks. And notice, we're going to find out that what he thinks is wrong. But But down on the bottom he says, well, observe him recollecting in sequence. He's remembering, he's recalling, as one ought to recollect. Interesting. According to Socrates, the slave boy is now recalling these things, as he has not been taught geometry. Now you tell me, you say the figure is twice the size produced, you say that the figure twice the size is produced by lines twice as long. I mean like this, not in this way, not short in that, but I mean he's going through a bunch of gyrations here, and basically he says, okay, we have this line AB, we're going to double it, right? Okay, and then we have this other line AD, and we're going to make DN same exact size. So now we have another two squares, and now we add the other one. So this is the one the boy has told us to make. And what's going to happen is Socrates is going to ask him, well, how big is this one? And the boy's smart enough to count up that we have 1, 2, 3, 4, so that's 4. And that's another 4 since it's 8, 12, 16. So now he comes up with 16. So what is Socrates going to ask him? Goes through and and this you say will produce a figure 8 square feet if there are 4 lines of this length. Yes, well, let's draw them. He draws them equally, counts them out. Then how big is it? Isn't it 4 times as big? Asks him a question. The figure that we've just drawn, it's 4 times as big. It's not twice as big. So now notice the kid made a mistake. Another way of thinking that is he has a false belief. And within one multiple, quadruple, 4 times. Then the double side boy produces not a double, but a quadruple figure. Yeah, okay, that is correct. Let's scroll up a little bit more, and let's see where he's going. But the bottom line is, after some discussion, he asks him, well, obviously, it's got to be bigger than A, B, C, D, but smaller than A, J, L, M, N, A. Right? It can't be 4 times the size, it can't be 3. So the question is, how big is it? And the kid comes up with the answer, well, let's split the difference in half. And then, of course, they're going to count it up, and they're going to find that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, or kind of 3 times 3 is 9. And then Socrates is going to ask him, it's 9. What number did you need? 8. So is 1.5 times by 1.5 times going to give you double the size? The answer is obviously no.